Hey Brittany, this is just a quick video to go over some of these factoring problems. The first one is this number 15. When I look at this equation, it's hard for me to see anything that I can really readily factor, but I know if I can put it into two separate packets, if you will, I might be able to do some more factoring that way. So I'm going to look at this first part at x to the third minus 3x squared. And when I look at this, I see that I can factor an x squared out of both sides of this. So I'm going to say x squared, and then that's going to leave me with x minus 3. When I look at my negative 9x plus 27, I see that I could factor a negative 9 out of that, and that would leave me with x minus 3 also. Now, when that happens, if I have two factors that are exactly the same, I can rewrite it like this. I can take my x squared plus a negative 9, so I'm going to say x squared minus 9, and I'm going to multiply it by my x minus 3. All right, and I can do that. And if you don't believe me, you can go back and FOIL it out and you'll see. But anyway, okay, so now that I've done this, I'm not quite finished. I haven't totally factored it because this x squared minus 9 is actually the difference of a perfect square. So it can be factored down to x plus 3 times x minus 3. All right, and then my x minus 3. So all of these x's are to the power of 1. So that tells me these are linear factors. All of them are linear factors. Okay, let's look at number 16. Number 16 says 3x squared minus 22x. And I see that the only thing I can really see is I can pull an x out when I'm factoring. So I'm going to factor the x out, and that's going to leave me with 3x minus 22. And that's really all I can do. Again, my exponent is 1, so these are two linear factors. All right, let's look at number 17. Again, number 17, I don't really see a lot. I could factor an x out of everything, but still, and a 2, but I'm going to just do a little bit more. All right, so what I'm going to do is I'm going to group these up into two sets here, and I'm going to factor something out of each of them. So in this first packet, I'm going to take a 2x to the third out. So I'm going to say 2x to the third, and that's going to leave me with just an x and minus 1. On this next set, I see the 4x squared minus 4x. I see that I can pull a 4x out, and that will leave me with just x minus 1 again. Okay, so you see that I have x minus 1 twice, so that works out perfect for me. So I can take my 2x to the third plus 4x as 1, and then my other one is going to be x minus 1. Okay, when I look at this 2x cubed plus 4x, I see that I have a 2 and an x I can take out of that. So I'm going to take a 2x out and factor some more. That's going to leave me with an x squared plus 2. And then I have my x minus 1. Okay, now my x squared plus 2 cannot be factored anymore. And x minus 1 can't be factored anymore, and my 2x cannot be factored anymore. So in this case, I have a linear equation, a linear factor, because this is x to the first power. This x is raised to the second power, so this is a quadratic factor. And this one, again, is a linear because the exponent is x to the first power. So I have two linear and one quadratic. This is a linear right here, this is a linear, and this is a quadratic right here. Okay, so I hope that helped you and cleared things up for you. Talk to you soon. Bye.